So Erica is an award-winning architect and Greenhammer's Director of Design. She has served as the lead architect on 5 net zero energy homes, 3 net zero energy pocket neighborhoods, and the living building certified tasting room at Cowhorn Vineyard and Garden. And ironically, one time, I just got to add, Eric and I happened to be down there for separate reasons, and we bumped into each other at Cowhorn when that tasting room was being constructed, and that was pretty fun. So Erica has served on the Portland chapter of AIA's Board of Directors and has been co-chair for the chapter's Committee on the Environment. She has also been an adjunct professor, guest lecturer, and critic at the University of Oregon. In 2012, Erica was awarded the, I always mess this up, Van Evera Bailey Fellowship for researching the human aspect of net zero energy in high performance buildings. Her research included post-occupancy evaluations of 9 net zero high performance buildings in Oregon and around the country, looking at occupant comfort and how to engage occupants in energy saving behavior. In 2017, Erica was named a Woman of Vision by Oregon Daily Journal of Commerce. So thank you, Erica. I'm going to go ahead and introduce Alex as well, and then I'll kick it over to you guys. So Alex is a certified passive house consultant and has consulted on dozens of LEED, passive house, high performance, and green residential projects in the US as well as in Europe. With more than 25 years experience in construction and building science, he plans and executes Greenhammer's innovation concepts and technical training, and ensures quality control of envelope, energy, and water systems in design, construction, and commissioning. So welcome, guys. Thank you so much. I look forward to hearing the rest of your presentation.
Awesome. Thank you so much, Ellen. Thank you, everyone, for having us. And I just want to add that Alex didn't put this, but he is not just doing that for Greenhammer, but he is so involved in the entire sustainability community in the Portland area that it's really, and actually nationally too, that he is a wealth of knowledge. And if you want to grab him and take him out for a beer, he usually will go along and talk about sustainability for hours on end. He's really quite brilliant. And I'm lucky enough to get to work with him. So we are here today to talk about zero energy buildings and how we have been incorporating zero energy and missing middle housing for the last few years, and sort of seeing that as a means of transforming our communities for a resilient future. And we're going to talk a little bit about how we do it, and then do a couple of walkthroughs of some projects as case studies.
So Greenhammer has actually just celebrated its 20-year anniversary. So we've been around since 2002, originally like a contractor only, and then we realized pretty quickly that we needed to bring design in-house to really get to those aspirational goals that we were hoping to get to. And on top of that, we were realizing, returning this, we really were waiting for Erica to bring her, architectural brilliance to actually shape, these sustainability features that we're able to plug into our projects in actually like a pleasant form. And so, so we've been design built since then, which really serves us well to meet those aspirational goals. And we have been actually meeting the 2030 challenge now for 5 years in a row. So our projects are predominantly zero energy.
So this is the slide where we normally like to talk about why zero energy is important. And usually it's more esoteric, talking about parts per million and things like that. But if you lived in the Pacific Northwest in the last 2 years, you got to experience all of these events. So the September 2020 wildfires that had incredible, unprecedented levels of smoke and particulate matter in our air. February 2021, where we had the snowstorm that basically shut power down for some people for a couple of weeks. Actually, one of our Greenhammer staff was in his house with no power, and every day he had on one more layer of something on him to keep himself warm during that. And then obviously the heat dome from June of 2021.
Oh,
And I think one of the key pieces here is that not only is zero energy important for helping to slow climate change, but how you get to zero energy can make it so that our homes are more resilient. And so we're going to talk a bit about the passive house in that regard.
So how did we get to zero, right? So passive house came out now a couple of times, and we will go into detail what that means and why that is. But let's suffice that, reducing loads is really what it's all about. And then electrifying, right, which makes load reductions and make that possible. And we also, in addition to that, obviously reducing the amount of fossil fuels that get burned to power our homes. On offsite renewables is then what kind of like makes up the difference. After we do load reductions, now we can provide enough on-site generation or offsite. That's now like a transition we're making because our projects that are pursuing zero energy are getting larger and larger. Backup battery for resiliency. We will talk a little bit more about that too, like what that means, what we were capable of today in doing with backup. And then the missing middle piece is really this important piece to scale to a reasonable scale, right? So we're combining both. We're combining energy efficiency, which higher density allows us to be more efficient, with the need for housing, and yet do it in a scale that really is appropriate for the neighborhoods that we're thinking of placing those. So passive house approach, I'm sure many people have heard it, is originated in Germany, right? So there were physicists were tasked by the government to say, like, okay, we want to make our buildings more efficient, right? So if we are doing that, like, what is like the sweet spot in terms of improving insulation and enclosure efficiency, and how does that interact with mechanical systems? Like, what is the sweet spot there? So as opposed to like a green building certification, like LEED or the Living Building Challenge, this is focusing solely on energy. And we're saying, like, okay, we're focusing on one aspect and just with a certain excellence. And what they came up with is really this approach that you see here, roughly in those couple of keywords, which are most important, which is super insulation, airtightness, thermal bridge-free enclosure, right? And as part of that, we're really seeing, like, triple pane windows as kind of an important part of that enclosure. And we're going to talk about that too in a little bit, why that is. And then, interestingly enough, heat recovery ventilation. So like once we're airtight, we're ventilating. We still consider that a passive measure because we really don't condition the space actively. Like, all we're doing is we're capturing heat, depending on climate zone, either going out or coming in at a very low energy level, and make, so we keep our conditioned air inside the building.
So some of the benefits of passive house beyond just energy efficiency is that it allows for, there is improved indoor air quality. It also reduces peak loads. So if you just, you can essentially make any building a zero energy building by putting enough solar on the roof of it. The problem with that in the Pacific Northwest, at least, is that in the wintertime, you're really still drawing your maximum loads from the grid because there's not enough solar to cover all of your needs. And so by using passive house, you're actually reducing those peak loads, which allows you to have less of a draw on the grid, and thus less of a need for more power production. And so you're actually helping reduce the impact on the grid itself. And then those levels of super insulation have sort of a level of built-in resiliency around it, because in the same way that heat or cold doesn't get into the house very fast because of all of that insulation, also doesn't leave the house very fast. So in a situation where you have a power outage, you can ride that out a little longer before you actually need to be adding heat into a space if it's wintertime, that sort of thing. Anything else you want to add?
Maybe to,
yeah,
maybe to add to that. So as you said, like, okay, if we're like really airtight, which we want to be to control heat loss, mechanical ventilation is imperative, right, to provide fresh air. And now we have opportunities not only to increase comfort, right, because we're now providing fresh air at a rate that we need, to the locations that we need them in, but we also have now opportunities to filter, right? So that's really the key piece in some of these situations that we're seeing with outdoor air quality, where we can say like, okay, we add layers of filtration, which you will not. This is not possible in a conventional home or even like an older home, where like dust leakiness and stack effects and other forces going onto the house that like allow kind of like not prevent particulate matter, smoke and dust to enter the home. So air quality is improved just by virtue of energy efficiency. And the peak loads is not only addressing, which a really important part right now is on the grid side, what Erica was describing is that the utility still has to handle our overproduction or our needs in winter. So we're reducing those peaks, but we're also reducing the peaks and temperature swings in the house. So that improves comfort as well. We have it's just we're cruising more at a temperature that's comfortable rather than being exposed to high highs and low lows. And that in itself provides that resiliency. So for example, we've seen with the power outages, homes, that are built to passive house level, but they kind of drift through, even in these very cold temperatures that we saw with the ice storm, they only drift like a couple degrees a day. And so, even after a week of power outages, we're still, above 60, 65 degrees, even without any active heating.
And thank you for teeing that up for the indoor air quality piece. So during the smoke events of 2020, the owner of Greenhammer actually was living in one of our units at Tillamook Road, which is one of the projects we'll talk about shortly. And he had inside purple air monitor on the inside and connects into a large website. I don't know if anybody is familiar with purple air, but essentially there are people with readers all over the city. And normally when you go on to the website to see how the air quality is, you see something like the image on the upper left, where it's pretty good air quality, usually in Portland and the surrounding areas. So you get all the green numbers. And then during the smoke event, you can see we had incredibly high hazardous levels of smoke in the exterior. And so this is a screenshot. The big image here is a screenshot of the 305 parts per million, PM 2.5 that was in the surrounding area. And then the green 22 is the air quality inside the unit. Now he had to adapt the filtration system. We actually had not designed it to get it to that level to remove the smoke particulates, but he was able to adapt it with filters to make sure that it could do it. And I think this kind of air quality improvement is kind of, as Alex was saying, it would have been impossible in a standard home. So Passive House really does make you able to get there. And we've now been adding on filtration levels that our clients can more easily add onto their system during an event like this. You wouldn't want to use it all the time because it draws a lot of energy to move air through such a tight filtration, but during a peak event like something like this, it can be done in that moment.
Really what that speaks to is how we are like facing so unprecedented events that we really have to adapt. And so we have to, on one hand, we're trying to catch up, and really trying to build as efficient as possible. Because we understand that energy use reduction means fewer emissions, and hopefully slows down the climate crisis. On the other hand, we're already there, right? So we're now having to adapt to like, what does that mean? How do we design for future events, right? And we're saying like, okay, typically fresh ventilation, ventilation with outside air. I think this is a conversation we had, for a long time in the commercial world too. We're saying like, oh yeah, 100% outside air, and we will be improving air quality tremendously, which we have been until we, ran into these events of like this wildfire smoke that was unprecedented. And so now we're trying to respond to this. And again, being at that leading edge of efficiency really gives us the tools to be able to do that, right? So we're basically able to add like, filtration to meet really that need. This is an example that we're now incorporating basically into our standard practice. That like, okay, here's added filtration. Like, what do we do in these events? And we're just becoming more responsive to some of these events, building at that level of efficiency.
So now we're going to shift slightly to just talking about missing middle housing. So I think this has been a topic of conversation a lot in the last few years. So I think probably most people know what it is, but for anybody who doesn't, it was a term that was coined by Daniel Paralik, who is an architect out of the Bay Area, I believe, in 2010, as a way of describing kind of duplexes, fourplexes, bungalow, courtyard housing, the style of housing that you saw a lot of right after World War II, and we see it all over the city of Portland, but in recent years has not really been built very much. It was really creating these sort of, you see a lot of single family homes, detached single family homes, and large scale, 5-story full block apartment buildings. And so he wanted to talk about this type of housing that increases density, but without doing it in a way that makes it inappropriate for locating in a single family neighborhood. And so usually you are seeing a density of about 16 to 32 units per acre. And just to give people a sense of what that means, a typical city of Portland lot is 5,000 square feet. And so our density is really about 8 dwelling units per acre. So you're looking at anywhere from doubling to 4 times that on a given lot, which is, as RIP recently passed in Portland, and also HB 2001, allowing for more density. This is the idea, is that it's a type of density that can make sense as transition points between single family residential areas and commercial areas, or it even can be something that is of the scale of a large single family home, but might have 4 dwelling units in it. And the benefits that we see from missing middle housing is that it really creates walkable, transit-oriented neighborhoods. So interestingly enough, 16 units per acre is also the number you need to get to in order to make there be enough people that this idea of a walkable neighborhood works, that you can actually create enough business for small stores to survive and have enough walkable business coming through. Promotes affordability through smaller, well-designed units. So if you're getting more units on in a single location or in a single lot, they're not necessarily going to be, they're not all going to be the size of the standard single family home, which is somewhere in the 2,500 square foot range. And then the sense of fostering a sense of community and creating resiliency. There were a number of studies that were done, particularly after the tsunamis in Japan, that found that communities that had higher levels of social connection and interaction actually had a higher survivability rate, because they were community members who knew each other, could lean on each other, could work together to get through sort of some of these disaster situations. And so,
right, and
yeah, go for it.
Just one more turn, like one more point to that, like that type of housing, because the higher density, we talked about all the benefits that we all, I think, can really relate to walkability and community, but because we were building denser, energy efficiency becomes more, we realize more energy efficiency, right? So simple concept is, if you have a detached single family residence, you have 6 sides to the outside. If you have, like a quadplex or triplex, now you might have 1 or 2 or 3 sides facing to the outside, having heat loss or heat gain, and so it's a shoe-in for higher efficiency. What also kind of speaks to the scale is, right, when we're talking about on-site generation, we have a limit, like we have a certain real estate that we can actually harvest the sun for. And in Oregon, it's about, like 3 stories is kind of the limit for on-site generation, right? Because if we have, again, like a level of density, like if you have 4 units instead of 1. We have also 4 kitchens, right? And the number of bathrooms. So now we have to make sure, yes, density is good, but what's the right level of density to be able to generate on site? And that's when we're saying, okay, zero energy has been always, for a long time defined as like on-site generation. As we grow, these efforts, we have to look at offsite, which is then becomes a little bit more interesting in accounting and where do those offsites arrays live. But, again, like for us, it feels like this is what Portland needs. It's a great density. It really fits into the neighborhoods, and we will be able to really offset, like 100% of our energy use on site. Okay, so here's some case studies, like what's some of the projects we actually have done. Like, so Ankeny Row, was like our first, that was a 6-unit development on Ankeny and 25th. It was the first development of that kind. It's actually the first zero energy development in Portland, completed in 2015. Like I said, 6 units. They're like 3 bed, 2 bath, 1,300 square feet roughly, and a common house. So like on the left-hand side, it's actually, I should have added, there's a smaller unit upstairs. So there's like an apartment upstairs, and downstairs is the common house. What's also interesting is they're intentionally decided against off-site parking, off-street parking, because it's, as you can see, it's the bike boulevard right in front. They're all avid bike riders. And so on the left here, you see the driveway that was always intended for 1 car to share, right? Which they really haven't had the need to do yet. So they're doing bikes only. The interesting one here is because we, so passive house, again, we're talking about load reduction. If we're talking about zero energy, we always have to reduce loads first, right? So to make that work, on-site generation, load reduction is imperative, and passive house is really the best path to that. And if you look at it, so we have 6 units and it's a 24 kW array, so kilowatt hour, which produces probably around 26,000 kilowatt hours a year, which is extremely low if you divide it up per unit. And this is where we see the efficiency when services are combined, units are attached, and so forth.
And in terms of the design of the project, the 6 units are organized around this central courtyard. You can see in some original renderings, as well as the actual final built courtyard. And I think one of the things that works so nicely here is that there is an entry to all of the units off of this courtyard. And there's also these sort of layers of privacy that are built into it. And so there's the space for, you can actually be outside your home, but maybe feel a little bit tucked back. And then if you really want some privacy, you can be outside, but still upstairs in that space. And that's the intention behind this sort of thicker or heavier railing that we had up here, is that people could really tuck back there. If you went in there into the space now, you almost can't see the buildings at all. The landscape has so grown up around it, which has been really lovely to see that. But that idea, this everybody, if they had their own private yard, would have a much smaller space to themselves than when we share it all together. And they have a lot of vegetable gardening that going on in this area, and this sort of gathering space that they can be together in. We should also say that this was a development that was started by 2 couples who then brought in, found 4 more couples to join in and be part of the community together. So they're all owner occupied units.
Which is
yeah,
go ahead.
I was just going to say, it was an age and place development. So everybody was a retiree coming into the space together. I'll let you go now.
Yeah, it's just like the image before really illustrates that this scale of housing also, like they're all walk-up units, right? So no hallways. It really gives you a sense still of home, on like the traditional sense. So it's really appealing, like this townhouse concept. That still gives you the best of both worlds, right? The privacy and the sense of like your home, as well as the community and the efficiency. Sorry about that, but yeah. they're just really lovely units. Like we're still in touch with them very much, and there's tours of the project still to this day. They're very engaged owners, so they're open to this. But what's interesting here is like to show again like how we're approaching certain aspects. So agent place means that one of the bedrooms is downstairs and the bathroom, which is I think visitable, but not quite ADA, but like with in mind mobility, and then upstairs 2 bedrooms. So there's different owners actually utilize them. That was really interesting to see like who chooses to place their primary bedroom downstairs versus upstairs. That was interesting. On the other hand, when we're talking about the efficiency aspect, we've talked about all electric, which is really kind of like, you've noticed this is an effort we've been pursuing since 2015 to go all electric. The reduction of these loads again actually makes some of these technologies we have now feasible. Like, so heat pump technology is both used for space conditioning as well as water heating. Most people probably are familiar with ductless heat pumps. You can see them on the right here, the right image on the right above the door. So one of these indoor units actually has sufficient capacity to heat and cool the entire home. Right, so that's typically a unit that's the smallest unit available at the time, and typically designed for like a primary bedroom suite. We're using this to condition the entire house, and we still have issues of like having them be slightly oversized and some issues that come along with those. But because we are so reduced, like we can really perform well through the winter, even if temperatures outside are below design temperatures, we can still satisfy the needs of the house. In addition, you see on the left, the cooktop is an induction cooktop. So, which was really helpful with the event of the induction technology, because you've probably dealt with clients who like really enjoy cooking on gas because of, how responsive it is, and like kind of like, there's lots of chefs who say like this is the only real cooking. Now we have induction, which kind of mimics that pretty well, because besides of the cooking behavior, we really introducing a number of carcinogens and other contaminants when we cook with gas, right? So not only from the cooking itself, but combustion really has an impact on indoor air quality. So not only are we reducing energy demand by using induction cooking, we're actually, again, improving indoor air quality. Something that's interesting here to see, which you can't really tell, but this exhaust hood is actually a recirculating hood, right? So we were, in 2015, we were really prescribed to efficiency, and we said like, okay, no direct exhaust, right? Our dryers are ventless. Our hood is recirculating because we were banking on the exceptional ventilation, right? So heat recovery ventilators that would address all this, right? So basically our hood in this case turns into like a grease scrubber, and then like odors, contaminants, and humidity risk get exhaust with the HRV. Now, that's a kind of a tricky proposition. And since then we said like, okay, no, indoor air quality is really so imperative to us that we're since then went back to direct exhaust hoods, because we really feel like it's so important. However, we did some research with students at PSU to say like, well, how well is actually our HRV performing in a cooking event? So we had like a couple of units where we cooked a prescribed meal on the induction and had the HRV on boost, which we recommend when we cook, and compared that to the direct exhaust of a similar house at similar size. And we actually had, the decay is what that's called. The decay of contaminants in the air was as fast with this recirculating hood in an HRV as it was in a conventional direct exhaust hood. However, it needs some kind of like conscientious operation of the owners, right? So you have to make sure your hood is on, you have to make sure your HRV is boosted and things like that, that we're since then really moved away from this, but that was one of the measures we had there. So this is where we learn. And the same idea on the right, that fireplace is an ethanol fireplace, right? So alcohol fireplace. Again, no flue, no vent, so like no thermal bridging, no penetrations, right? So it was really geared towards efficiency. And so the alcohol really felt like, okay, it still gives a sense of place. In fact, a wood fireplace would not work in a passive house, in a house of this efficiency. We would like simply overheat, right? You would have, you'd be able to like put 2 logs in there and you would probably have enough heat for a week. So an ethanol fireplace lets you control that a little bit more. Again, those are typically burned very clean. And with the HRV, we have indoor air quality that kind of matches that. Since then, like you probably have heard, like a lot of the green certification, want to step away from combustion, period, right? It's just an easier way to think about this. Like, let's not combust anything, because we're not in the place where we really can offset that sensibly. So we're looking at alternatives. I mean, a fire in the home is a really important thing for a lot of people. There is alternatives, like there's, steam electric fireplaces that mimic fire really well. However, it's not quite the same. So it's an interesting design challenge for us to, like, how do we provide that and yet keep indoor air quality, in front and center. So this is really the group on the left. Those are the owners who are really committed from day one to the passive house concept. The density. There are folks in here who have been lawyers and urban planners, so like they're really in tune with the needs of the time, and they really wanted to show what's possible. And really came to us with like what they wanted to do, and we kind of picked that up and really provided the technical and artistic expertise to that. On the right, it was just really to give you a sense of, at the time, on the right, that's Dr. Wolfgang Feist. He's actually the founder of, the developer of the Passive House Standard and the Passive House Approach, and the founder of the Passive House Institute in Darmstadt, Germany. And we were lucky enough to have him here at the groundbreaking ceremony, because it really felt like, okay, these strategies of load reductions are so important for us, that communicating them as best as possible at the time was key. And so we were really glad to have him and get some exposure, because we're a firm believer of that. That's the road to the energy efficiency and low emissions reductions that we need to get to.
Thanks. So the next project that we wanted to share is Tillamook Row, which we designed in 2016 and finished up in 2018. And it is located on Northeast Tillamook, just off of Williams. So it's one of those sort of end caps of, meaning that we're sort of in a single family residential neighborhood, but butted right up against what is a major commercial street. So again, it felt like a really good location for having this density of housing, and it's only located about 1.5 miles from downtown Portland. So a great location for easy access on bikes to downtown. The overall site plan, it's 16 units with anywhere from 1 bed, 1 bath to 4 bed, 2 baths, square footage in the 750 to 1,300 square foot range. A shared common house here in the center, and it required a 96 kW system to get to 0. And again, same idea as we had at Ankeny Row, located around a central courtyard. And all of the units are entered off of that courtyard as well. This one does have a little bit of parking, although not enough for everybody in the development, but wanted to have a little bit there. There are also 2 electric car charging stations in this parking zone as well, and also has its own separate pedestrian entry through here. Interestingly enough, at Ankeny Row, that when this was built, and at Ankeny Row, that pedestrian entry was left open, and it still is at Ankeny Row, and they've not had any problems there. On this site, they ended up adding a fence here. There is a gate at the parking area as well, because they had a lot of problem with bike theft. And we sort of, while we really like this idea of this sort of centralized courtyard, we understand, like, as a lesson learned, that in some ways, it's sort of removing, there are still the eyes on the street of the housing around it, but not as many eyes on the street as if it were actually opened up. If this were a larger opening here, it might actually be a safer space in that regard, and they wouldn't have necessarily needed that gate on there. And maybe that's getting to the point where 16 units is maybe pushing the limit at, you don't necessarily know all the friends of the people who live in the units. So somebody could come into the area and not realize that they're there with bad motives to be there. So
yeah, I think the conversation around like the sense of place really, becomes a bigger conversation. I mean, there was definitely different times between Enkidu Row and Tillamook Row. But the sense of scale and how it interacts with the neighborhood becomes a really important aspect. And so we recognize that too, that reaching out to the community more proactively early on to discuss the project, I think is important for this integration, because there's so much that we have to show for. But if it's not understood, it can be kind of complicated. And I think Ankeny had the benefit of being more blending into an existing, like on all, there's commercial on the street, left and right, there are 3-4 story buildings. So it kind of more or less kind of like just blended into the street facade, where this is almost at a corner, with lower buildings adjacent to it. And so it's more exposed and more obvious, that there's a development that is new and, and that might be attractive to like just check out and maybe not always with the best intentions.
So just a quick section through the site, just in terms of getting ourselves to zero, obviously making sure that you have enough south facing. So south is to the left on the screen. Having enough south facing roof is always a critical part for site organization. We set up 2-story units on the south side so that the courtyard would get enough light as well. There were some 3-story buildings across the street from the project as well. And so they related a little bit better as well on that scale. And then again, all entrances off that central courtyard, kitchen windows that face out into the courtyard so that you have a little bit an opportunity for connection with the neighbors. But at the same time, if you want a little bit of privacy, you can move into your living room space and not feel like you're on display that whole time. And then really looking at the shared amenities for creating that sense of community and a sense of reliance on one another. So this project has rainwater collection that's used for irrigation, an outdoor courtyard that can be used even during COVID. So this picture all the way over on the right is actually a photo that one of the residents sent to me to say how much they really, this is actually early on in the pandemic, we're really thankful to have this courtyard so that they could still get some interaction and engagement with their community, but still being socially distant. And then again, just that reliance of community food gardens. I think one of the other things that's really great about having the 1-bedroom all the way up to 4-bedroom meant that there was really a range of unit types there. And so you could get people at all phases of their lives. And it is true, there are retirees who live there. We again did the 1-bedroom and bathroom on the ground floor, even in the 2-story units, so that there was an age in place quality to it. There were some single parents who lived there. There was one of the 4 bedrooms was at a time occupied by 4 college students who were all renting it together. And I should also say Tillamook Row is 5 owner-occupied units and 11 rental units. So it actually gave people an opportunity to try living in a space like this, even if they weren't necessarily looking to buy a home at that moment. And then some of the last pieces around resiliency. So there's that central commons house, which you see a photo of there, which we actually turned into a resiliency center by having a battery backup in that space. It also serves as a community gathering space. It's the gym there. And they have this sort of shared energy, they have a shared energy goal, a zero energy goal that they can kind of come together around. And so you can see the reader board here that's up on the screen in the community house, letting you know how many or how much energy you are using. And this was designed to show that everybody had a budget for a week of energy usage. And if your energy use was doing well, you were in the blue. And if you were sort of starting to inch towards, an energy usage that when you multiplied it out would put you over your budget, it started to turn yellow. And then if you were really over, it would turn red. So that just at a quick glance, you could see, how am I doing generally this week? Do I need to be watching my energy usage? Or even seeing that, 42D is always in the blue. How do they do it? And talking to them and finding out like what their energy use looks like.
The key also was that that was a really interesting exercise. So feedback, like energy consumption feedback like this can really have a huge impact. And there isn't great research on it, but the assumption is like 7 to 12, some say like 15% energy reduction, which would be giant, which is really like some great efficiency. And so we were really trying to design this as a viable feedback option, because so that means we did like weekly budgets, right? To keep really the time frames that relatable. So people can walk by there, glance at it, say like, oh, I'm high. Why am I high? And they can think back like, okay, what have I done? Maybe oh yeah, I did all my laundry or whatever. I had a party, and then it's good. But if it would be like, for example, a monthly budget would be much harder to relate to say like, okay, well, 2 weeks, 3 weeks ago, I don't know. And so people wouldn't be able to really adjust their behavior as well as like shorter time frames. So that was the idea. And then it's working. And so it's not only working in efficiency, again, like the feedback in the sense of community, like we had discussions around this, be like, like, hey, what are you doing? What are we doing? So that's really, that was really beneficial to do that. Batteries, right? So in terms of resiliency and backup, like the Common House also has a battery in place that basically services lights, refrigeration, and some plugs to charge cell phones, laptops. And initially I talked about batteries. So battery technology is coming a long way, and it's definitely changing by the minute. However, it's still like a tremendous expense. Energy storage is like really expensive. So battery backup really means, in most cases, backing up only very essential loads. Particularly heating, no matter if it's space heating or water heating, is typically prohibitive to do from battery backup, right? So another reason to like focus on the efficiency, right, of the building, the enclosure, so that we can actually keep the conditioning, space conditioning, as minimal as possible. And now backup becomes feasible because we have like, okay, lights, refrigeration, again, those are the safety items. And then something to charge a cell phone or stay connected becomes feasible. So in this case, it wasn't feasible for the entire development. So that's basically said, okay, we provide that in the Common House in case of a power outage, people can congregate there. In this case, we also added the HRV to the backup loads, because we're saying, okay, nobody, even if there's a number of people, nobody needs to open windows for ventilation and let out, our precious conditioned air, but we are providing fresh air. But with the heat exchange capabilities of the HRV, it can maintain indoor temperatures as long as possible. I saw a question there too. I don't know if you want to pepper them in now or later. On the ethanol fireplace, and as a resiliency measure, whether you could heat the home with an ethanol fireplace. You certainly can. It's a real fire. It puts us like some real BTUs that would be near the capacity what's necessary. So it's an option. In this question, it was like, okay, how does that relate to gas? Like we were saying, like we want to go all electric, but get gas, like in a gas fireplace could be a backup. Obviously a furnace wouldn't be, because we started a blower that required energy, but a gas fireplace could potentially be backup. So yes, right? So that's a good question to ponder. But I think if you're focusing on the efficiencies and, like hope on the development of new technologies that we can really, forego gas connections. The other one that's really like when we talk about construction cost, there is real cost associated with providing another service, right? Mm-hmm. So by saying like, okay, we don't even bring gas to the house and no gas piping, there is some cost savings there. So really making that step all the way would really be beneficial if that's possible. But Other than that, gas can be, like, again, we don't need much to heat the home, but again, like if we are having gas fireplaces and our HRV is not running, are we still providing appropriate indoor air quality, right?
Mhm. Cool.
Um,
Just in the
yeah,
interest of
go ahead.
time, I'm going to hit our
Yeah.
last two slides and then we can open it up to more
Yeah,
questions if that
sounds
sounds good.
great.
Cool. So
Sounds
the sort of where we're seeing the future of zero energy going, seeing passive house being required by building codes. It's already true in places in Europe, and you're starting to see it more as part of the REACH code in some places. So seeing it becoming required really helps to drive down costs, because you now have more people who are trained to build this way, and so that can bring costs down. Using panelized construction as another method to drive down costs to make this kind of development affordable to everybody. And then the use of electric cars as battery storage for solar is really going to be a key piece to make it so that everybody has this available to them, and that we actually can start reducing even more the impact on the grid altogether. And then the last thing we wanted to hit was just what you can do at home. So the first we'd say is go electric and decarbonize your own home. Electrifynow.net is a great resource for all kinds of webinars that they've done about how you go about doing that and things to look for. Replacing your old leaky windows to make them triple pane. And even doing that ahead of installation actually has the biggest impact on your energy usage and your comfort level in your home. Insulating with dense packed cellulose, so having people drill holes into your siding or from the inside and blowing all of the stud bays full of dense packed cellulose, and then installing solar panels on your roof. And solaroregon.org is a great organization to follow up with around that.
Yeah, and just a word to codes, just real quick, because that is where codes are going to. They're going to, passing building standards. This might be interesting for this group because, like staying ahead of the curve, like really understanding where this is going. It, depending on where you are, it might be a matter of time, but in 2 or 3, I think more likely 2 code cycles, we will be probably at passive house level. So that's an interesting development there.
Mm-hmm. So I think there's our email addresses. You should please feel free to reach out if we aren't able to get to your questions today. We're happy to answer more there. But I'm going to stop sharing and then we can have more Q&A.
Yeah, thank you so much, you guys. That was fantastic. I'm going to just facilitate a little bit of the Q&A here. Nathan puts in a great question. It's a little bit long to read here. So I don't know if this is one you might want to follow up with him later.
I'm going to copy and paste that into something so we can make sure to get back on that.
Nathan, that's fantastic. Lots of good detail and numbers there. So I think maybe, would it be okay with you, Nathan, if they followed up with you later?
Yeah, the basic question is that, we're not done with fires. And I found that I had to shut my home down. I had to shut off my HRV in the fires, and then my CO2 levels, shot up.
Right.
And indoor air filtration didn't work. So what do we do?
Yeah, it's a great question, just to illustrate that, right? So we produce CO2 indoors, right, and contaminate our indoor air. If we bring out fresh air from the outside, we dilute that, and so that's the benefit. Now, if the particulate levels outdoors are so high, then that doesn't become feasible, and you're kind of like in between the rock and a hard place. Are we bringing in fresh air, which isn't so fresh anymore, or we don't, and then contaminates? Levels increase indoors, and that's definitely the tricky part. That's why we're kind of like really focusing on higher filtration. So can we bring in fresh air still and have like higher filtration levels? And it's probably a combination of both, right? So you're describing recirculating, air cleaners, air scrubbers. People can, even if they have high filtration in the furnace, they can turn those on. So it probably has to be a little bit of both based on what the levels are.
Yeah, hopefully I checked in with Small Planet Supply, and they don't make a filter that'll screen out smoke yet. There are apparently some off-market options, but I haven't found anything yet.
Yeah, I mean, smoke is technically a VOC, right? That's what we smell. So we have two things. We have the particulate matter, like the dust and the ashes, and then we have the VOCs, which is the smoke smell. So if you can address VOCs, you're going to a degree address the smoke smell. But that's also, like, for health reasons, that's less concerning. It's really the particulate matter, which we're doing a pretty good job now, with HEPA filtration to filter out if we can incorporate that in our filtration, in our ventilation system.
Thank you.
Yeah, thanks, Nathan. And Jan, you also have a great question with some information. It almost looks like a little bit more of information about emergency generators. Would you like to jump in and share that with the group?
I think he might have already jumped off, actually.
Okay,
Yeah, he's not here anymore, so.
okay, great. And then Erin is ready to move in. She's
excellent.
she's good to go. So I think you have your next tenant there.
Great.
Awesome.
And that's all I see as far as questions or comments. Anyone want to? We have a couple minutes if anyone wants to jump on and just kind of freeform ask something.
How do we optimize views and daylighting with the passive house?
Is that daylighting specifically? You're saying?
Cloud cover in the northwest. How do we maximize the amount of daylighting to our interiors, and what do we do if we have a site that has just amazing views and the client doesn't want to lose those amazing views?
We run into that actually quite a lot, and from the view perspective, depending on the direction that it's going and that you're bringing in, it would be shading to make sure that you can control when you do let that light in and when you don't want it to be coming in. I mean, luckily, south-facing windows, if you have is a great way of bringing in daylighting, but it's also a good way of bringing in heat in the wintertime when you want it. And that's a benefit in the passive house scenario. And then it's much easier to control. So it's really the east and the west that can become a little bit tricky in terms of providing shading. I don't know if you saw it on the Tillamook Row project. We actually had sliding shades so that people could actually pull that in front of their east-west windows in those scenarios. But definitely figuring out ways around the east-west views is always tricky.
Thank
I
you.
mean, what you might also be alluding to is that, like, windows, even triple pane windows, are like still the weakest link in our enclosure, right? And north facing glazing can be basically energy penalty. But then we have enough tools, I think, in the toolbox to compensate for that if that's necessary. We did have a project that was very elongated and views in the wrong directions, and we actually moved to quad pane, right? So 4 panes, because we really wanted to meet the passive house standard. So there is still tools, and as we practice more, we can optimize, and hopefully we can capture those great views without sacrificing the passive house standard. But even if it's near passive house, the important one is to reduce the loads as much as we can. And even if we're very close, I think it's a great service to the occupants and the community, by using less energy. All
right, thank you so much. It looks like we're right at 6 o'clock. So
well done.
Do you guys have any parting words to send us off?
Just zero is possible, so go for it. And there are lots of benefits to clients beyond just the energy efficiency. And so as we're seeing more and more of these natural disasters, unfortunately, it is actually becoming easier to convince clients that there's real benefit in doing this. People aren't asking quite the same questions around, well, what's my payback? Because it's hard to calculate payback of being able to breathe the air in your home.
Yeah. Well, thank you so much.
Yes, thank you.
Thank you, everyone, for joining us, and we'll see you again soon. Great presentation, guys.
Thank you.
Thanks for having us.
Thanks.
Thank you.
Thank you. Bye-bye.
Bye.